In the last video, we looked at the networking components, reviewed clients, servers, switches and routers, and where they sat in the network. Well, in this video, we're going to take that knowledge and expand it into the networking architectures. We're going to review the enterprise models, which is the 2 and the 3 tier models. We're going to look at the DC model, which is the leaf and spine. And then we're going to look at the off prem and on prem. What's also worth knowing is I done a video for the CCNA back in a couple of years ago now, and that covered things like hub and spoke, full mesh, star, bus, ring. Might be worth spending sort of 10-15 minutes looking at that video. I'll link it in the description. And this actual video here with the network and architectures covers the CCNA. It's network fundamentals, and it's 1.2 on the blueprint. So let's get started. Hello and welcome to the CCNA training with me, Ryan. And in this section, we're going to look at networking fundamentals and the subsection 1.2 networking topology and architectures. For those who don't know, you can contact me here on YouTube, Facebook, Twitter, and LinkedIn. And if these videos have been useful, please do like and subscribe. So first up, we're going to carry on with something that we briefly touched in the last video, which is the WAN and LAN. We just want to expand on this concept and make sure we're all happy with it before we move on, because it's an important concept not only in your career, but also outlined on the Cisco blueprint. So first of all, what do they actually stand for? Well, we know LAN stands for local area network and WAN is wide area network. Again, something we picked up in the last video. Well, what I want to do is just bring up a networking topology and just quickly have a little discussion about it. So first of all, now we've gone over the networking components in the previous video, we should be able to look at this diagram and quickly identify what devices are doing what. So we know this is a firewall, we know this is a router or a router, we know this is a switch, we know these down here are servers, we know this is a access point, and we can also see that there are endpoints here, a laptop, PCs. Now we can see the access point connects into another switch via the Ethernet cable, and we can also assume that these switches also connect via Ethernet cables. And then there's another uplink here, so remember we're going upstream, and we can also see that there's a firewall also here. So there are mobile firewalls in the network for probably extra security. And then last but not least, we can also see that there's a cloud in the network. And again, a cloud represents something that we don't have any control over or we simply don't care about. So this is our network. Now, from this perspective, we can easily say that devices behind the so-called cloud, so here, is most likely going to be the LAN. Meaning that this is inside our control, and it's a local network to us as an administrator, because we sit here and we manage these devices. That also means that anything above this in the cloud is considered the WAN, the wide area network. But what's really important to understand about LANs and WANs is they're actually very much a perspective thing. So let's say, for example, that we got rid of this cloud and we kind of knew roughly how the ISP has their network set up. And what we've actually done is this cloud, this firewall plugged into the cloud, well, realistically, what that actually is a router provided by the internet service provider. And this is their what's called demarcation point. So they're in charge of anything this way, and you're in charge of anything this way. Now, from the perspective of an ISP, let's say, for example, their router that they provided on site, which is this one, from them, this is the WAN, and this is the LAN. Despite you thinking that anything above your firewall is the WAN, and anything below your firewall is the LAN. So you can see that it's kind of a perception thing, that from an ISP's perspective, that your WAN connectivity is part of their LAN. Now, mostly you don't hear things like this in the real world, kind of in the sense of like an ISP calling it the LAN and so forth. But I kind of just wanted to give you a perspective on things where a LAN is sort of downstream and a WAN is sort of upstream. And you may hear from time to time, sort of depending on perspective, these terminologies to be used a little bit different. It's worth knowing, but essentially for the exam, we need to know that LAN is local inside the premises, WAN is remote outside the premises. Simple as that. networking architectures that we have available to us. First of all, we're going to have a discussion around the 2-tier and the 3-tier, which is referred to or falls into the category of enterprise topologies. And then we've also got this other one which we will discuss, which is leaf and spine, and that falls into the DC. So it's important to know that there are different categories within the models. There's leaf and spine, which lives with the DC, and there's 2-tier and 3-tier that lives in the enterprise. And in this section, we're going to have a look at the 2 and 3-tier, starting with the 2-tier. Now, it's important to know that there are a lot of differences between these designs, and these are kind of referenced on Cisco models, but of course the design will vary depending on the environment. So this is kind of like an ideal design, but unfortunately doesn't hit every requirement necessary out there. But nonetheless, it's important to understand these designs because normally your network that you're working on will fall into something very similar to this, as long as you understand what the different tiers are doing and the different kind of models inside those tiers. So what is access doing versus distribution versus core, it helps you understand in the real world. So first of all, let's have a look at sort of the 2-tier design. Now, first of all, there are kind of 3 names that we call these tiers. That's the first thing to know, which is core, distribution, and access. They're the 3 kind of names, if you like, that you call each of the tiers. And Tier 3 has all of these tiers. Tier 2 has 2 of these tiers. But the way they do it is they actually flatten or merge, if you like, the core and distribution. So if we look at this diagram now, we can see that the core and distribution is here and the access is here. So it's kind of, it's merged ultimately. You can see next in the next slide when we look at the 3-tier, the 3-tier is when the core and distribution is separated and there's a third sort of tier at the top that we refer to as core. The middle becomes distribution and the bottom becomes access. Now, what's really, really important to understand when it comes to understanding these tiering structures is what separates a tier is the roles that each of the tiers perform. So, what do I mean by that? Let's have a look at access. Access is the bottom tier, and when I say bottom, I mean it's the tier that's facing the end users. So remember when we looked at our networking components, we said PCs, servers, access points, all of that. Well, normally they all sit off the access layer. And the access layer has one job, and the job is to simply provide access. And it does that through the use of switches that are normally very high port density. And what I mean by port density is it has a lot of ports on it. So you see them with 24, 48 or more ports, and each of the devices will plug into the access layer. What you won't find or shouldn't find is a PC, for example, plugged directly into the distribution layer. So the idea being is that all of your users connect to the access layer in an enterprise model on all designs. That's the way it should work. And the reason for that is, again, the switches that you're kind of installing at this layer are high port density and they're very basic. So they don't need to do anything fancy. They just need to have a lot of ports and a lot of bandwidth available for you. They don't need to do things like quality of service. So that's prioritizing certain traffic over other traffic. They don't need to do access control, denying or allowing certain traffic. They can simply just say, here's a port, get onto the network. Simple as that. Not the same when we have a think about the next level up. And the next level up is, of course, the actual distribution and core. So again, here, the distribution and core are collapsed, and as such, both rows of the distribution and core are performed by the same devices. And the main roles of the distribution and core is, first of all, this is where layer 3 is normally introduced. Now I say normally because there's nothing stopping you from running layer 3 at the access, but most of the time you run it at the distribution and core. Now you might be wondering, well, what's layer 3? Layer 3 is where we start looking at the IP addressing. And again, layer 3 and this terminology of layer 3 is not being spoken about yet because we've not gone through the TCP and OSI model. But some of you may know what I'm on about, some of you may not. If not, don't worry. For now, just make a note that layer 3 is IP addresses, and IP addresses tend to live at the core and distribution, and it will come clear as we continue through your CCNA studies. What we also require the distribution and core to be able to do is aggregate all the traffic that the access is sending up. So let's say each of these ports down here, 1 gigabit per second. Well, what we need to make sure is that these uplinks here that are going towards the core and distribution have enough capacity. Let's say they're 10 gig to ensure that all the users that are connected to it are able to have some decent bandwidth or some decent performance. Well, we need to make sure that when you have mobile 10 gig uplinks coming from each of the access, that these core and distribution switches have enough ports and capacity to handle that aggregation of traffic. So we're looking for less ports but more performance, so higher sort of bandwidth for the ports. So they do layer 3. This is where IP is. We want better speed or bandwidth for those ports. We also here, this is where we introduce things like QoS, quality of service. So if there's a phone that's connected to the network, we need to make sure that it's prioritized over other people's traffic. So that's where QoS comes in. We also start to do access control here. So if there's a particular user that's sitting on this access switch that wants to communicate with this PC over here, and the traffic flow for that will actually go up towards the distribution and core, well, the distribution core will have a look at that traffic and allow or deny it, rather than doing it at the access layer. So a lot of the clever sort of networking or the actual interrogation of the traffic, all of that happens at the core and distribution. It doesn't happen at the access layer. The access layer, again, is very basic and it just wants to get people online. What I'd recommend also is when you're looking through other materials like the books, make sure you're understanding what sits at the access layer and which sits at the distribution and core, kind of what roles they play in the network, and making a list of everything. So when I said previously that QoS sits here, access control sits here, port density sits here, make sure you understand where each of those roles sit in a standard 2-tier, 3-tier design. So if in the exam you're asked, where's QoS performed on a 3-tier model? You can say, oh, it's performed at the distribution layer. So you understand where it sits in the network. Now we've seen the 2-tier, let's have a look at the 3-tier. Now, what I've done here, I've actually done this on purpose, is you can see that this down here is clearly the access. So we know this is where all our users connect. And we can see that this is the distribution. But you can see that the core is actually a bit bigger, meaning it's not just one row of devices. It's actually 2 rows, one there and one here. And that's because not always is the demarcation or the differences between the core, distribution and access is this clean. Sometimes it's not. And also, remember, we're separating core, distribution and access more on what they're doing rather than where they sit. So we know that the distribution itself is performing sort of QoS, for example, whereas the core shouldn't really be performing any sort of QoS or access list or access control. And the reason for that is because the core is really about passing the traffic really fast to each of the switches in order to go off to downstream LANs. And the reason for that is because what we don't want is a bunch of traffic. Let's say we have, let's give you an example. Let's say we have a distribution network over here. We have access down here. And off the back of the access, we have another PC. The reason it's important we perform the right task at the right areas. So for example, the access control. Well, let's say there's a PC here. And this PC wants to communicate with this one. Well, the traffic flow, if I just grab a different color, the traffic flow will actually go up through the network, to the distribution, to the core, to the distribution, to the access, to the device. Well, let's say that the core was doing the access control. The traffic would already have traveled quite far into the network before it was actually declined. So really we want to decline it as close to the source as possible to free up the traffic not being utilized across links. So that's first of all why we have things like the distribution performing those access controls and distribution performing the QoS marking. So the core doesn't have to receive and doesn't have to inspect the traffic as much as the distribution layer. And of course, when we think about the access doesn't need to do any of this at all. It doesn't need to do inspection or doesn't need to do access control because its job is purely port density. So it's important that we understand all the different jobs, all the different tiers, and where those tiers fall in. So what is access, what is distribution, what is core, and how is a 2-tier versus 3-tier different. 2 tiers where we collapse the distribution and core into one, and 3-tier is where we keep them separated. And then we also need to know which roles come with which tiers. And then on the side note to that, which we're going to go on to in a moment, we need to make sure that we understand the 2-tier and 3-tier fall into the enterprise designs, and the leaf and spine falls into the data center designs. So let's move on to the leaf and spine, which is part of the DC design. So you can see straight away that actually it looks very familiar to the 2-tier design we've discussed already for the enterprise, because you can see that it's almost like there's access and distribution, but that's not the case here. A few things to know about the leaf and spine versus enterprise is something how people describe the flow of traffic. So for example, considering this is going to be in a data center, most of the traffic is actually between and to servers. So you actually see server 1, server 2, and when they want to communicate, they communicate through the spine, obviously because they don't have any links to each other. But what tends to happen is the traffic is from east to west. And what I mean by that is the data is across the data center to other devices inside the same data center. A lot of that traffic happens in our DCs, whereas in an enterprise design, it's north to south. And what I mean by that is if we go back and draw it, we've got our client connects into our access, connects into our distribution, which connects into the core. Well, let's say we have 2 clients plugged into the access. The traffic rarely goes between the clients. It actually tends to go north to the internet or out of the network. So most of the traffic is north to south. In a data center, it's east to west. It's within the data center and it's normally between devices in the data center. So it's worth knowing that that's the terminology when people refer to east and west and north and south. The other thing that's worth knowing is the leafs themselves actually has multiple uplinks. Notice that every single leaf connects to every single spine. And the reason for that is bandwidth. In our enterprise design, we normally only have 1 or 2 uplinks from the access. So we'd have, again, 2 distribution switches, and we'd have our access switch, and sometimes you'd have only 2 uplinks for resiliency. Whereas in this scenario, we're after resiliency, but we're also after bandwidth, because this is where all of our servers and all of our hosting sits, and the traffic between 2 and this actual data center was going to be high volume. Therefore, we need to ensure that there's no bottlenecks in the network. The actual leaf and spine architecture also isn't as clear cut. You tend to see it all running at layer 2 or all running at layer 3. Whereas in a enterprise design, you normally see the distribution running at layer 3 and the access running at layer 2. So spine would be 3, leaf would be 3, or spine would be 2 and leaf would be 2. So it's kind of one or the other when it comes to a proper leaf and spine design in a DC environment. So at the CCNA level, really, all we need to know about is when we look at the architecture like this, that we're able to know that it's probably a spine and leaf part of a DC design rather than a core access and distribution part of an enterprise design. Up next, we're going to have a discussion about on and off prem in regards of hosting. So in the blueprint, Cisco wants us to understand this concept of what on and off prem actually means, and it's really simple. Ultimately, it means whether you are doing something on, as in within your infrastructure and within your sort of site or within your DC, or if you're doing it off-prem, which means off the premises, i.e. in the cloud. So, give you an example of that. Let's say we have our network, so a router. The router connects downstream into, let's say, a switch, and the switch connects into where our PCs are connected, and off the back of the router we've got another switch, and we have a server, and this server is doing all of our emails. So we have hundreds of users in our infrastructure, and they're all speaking locally to the server in order to obtain their emails. And the way that works is you've got something out on the internet, and this server communicates with the internet, downloads everyone's emails, and then everyone communicates with the email server and obtains their emails. Very straightforward. Everyone's happy, and it's on-prem because it's inside our premises. Well, what happens with off-prem is we put in consideration as network engineers the cost of actually having this server running, the uptime. So maybe the server crashes very often and we have to go to the office to actually physically reboot it. We also put in consideration how much skill we have on site. So maybe we want to maintain the server, maybe we don't want to maintain the server. And we put all these things into consideration. And sometimes we decide, actually, it's probably best that we pick up this email server and we put it off-prem in the cloud. And what we mean by that is we have some secure method to put the email server in someone else's network. And someone else's network could be a cloud provider like Amazon Web Services, Azure, Google, or it could be a third-party company outside these sort of cloud infrastructure hosting companies. And that could be anyone at all for us. But ultimately, the bottom of the line is it's not on the premises. And by doing this, we have a few benefits. Sometimes it's cheaper, sometimes it's not. Like, for example, it might be that we now pay monthly for that hosting, but we don't pay a large fee up front in order to buy the server. It might be that because the off-prem hosting company, like for example AWS, has service level agreements on how often or how much they guarantee your server will be available, then that's more of an uptime than what it would have been if it was still on site. And it requires less skill because all of a sudden we don't have to worry about RAM, we don't have to worry about CPU and all these other little things because the physical attributes of that is handled by the cloud provider. So there are benefits and there are downsides of doing something like this. Obviously, as cloud, as we know, is more complex than it used to be when it first started. There are now specialists in actually getting qualified for that. So some elements, like for example, skill, is now obviously we do need people skilled in AWS to be able to handle that. But maybe it's not, depending on your end, depending on your experience, it might or may not be easier. So it is pros and cons ultimately for having it on or off-prem and in what we call the cloud. But ultimately, that's the difference between on and off-prem. Do we have it inside our premises and delivering the service to our end users? Or do we pick up that server, pick up that service, move it out of the premises into the cloud, into someone else's office, and allow them to maintain it for us and provide a service level agreement on the uptime for that service or server? That's all we've got time for in this video. Just to recap what we've done, we went over the LAN and WAN and understood that this will vary depending on perception and where you sit in the network. We looked at the networking components, so this was to see where clients sit, service suite, routers, and that was kind of a refresh from our last video. We jumped into understanding the 2 and 3 tier topologies that is offered into an enterprise, so that's the access, the distribution, and the core, and which jobs sit at which tier. And then we jumped on to understanding leaf and spine, which is used in the DC and how that differs to the actual tiers and topologies that are used inside the enterprise. And then we finished off by looking at on-prem and off-prem in the sense of hosting and reviewing what that terminology actually means. Other than that, I'd like to thank you for viewing and I hope this has been informative. And if it has been, please do like and subscribe.